Hey guys, it's Sadiya here at the Math Center. Today I'm going to be talking about how to take antiderivatives of functions. So you guys probably already learned how to take derivatives. If you haven't, you can go and watch our 3 other videos. So basically a derivative is the reverse of an antiderivative. So when we take the derivative of something, the thing that we're taking the derivative of is the antiderivative of the derivative. So say we're taking the derivative of this function x to the fourth. The derivative of x to the fourth is 4x cubed. So 4x cubed is a derivative of x to the fourth, and that means x to the fourth is the antiderivative of 4x cubed. So this is the antiderivative. So when we're trying to take antiderivatives of functions to some power, we pretty much do the opposite of when we're taking derivatives. So the rule we use is this. So the integral sign is this little s-y thing. So if we have x to the n power dx, the antiderivative of x to the n is x to the n plus 1, so we raise it the power by 1 and divide by the new power. So divide by n plus 1, and we have plus a constant here because when we take derivatives, the derivative of a constant is 0, so it goes away when we're taking the derivative of it. So therefore, when we take an antiderivative, we need to add a constant term. So let's go ahead and do some problems. So the first problem we're going to do is this one. So we're going to take the antiderivative of x cubed plus 3x squared plus 5x plus 1/2. So when we take antiderivatives, just like derivatives, if we're adding functions or subtracting functions, we can take the antiderivative of them separately. So we can do each term separately. So for this one, we're going to split it up into 4 separate integrals. So the integral of x cubed can be written like this, plus the integral of 3x squared plus the integral of 5x plus the integral of 1/2. So now using the power rule for integrals, we would get, for the first term, it becomes x to the 3 plus 1 power divided by 3 plus 1. And then the second term, we would get 3x to the 2 plus 1 divided by 2 plus 1. This one is 5x. This 5x has an invisible power of 1 that we usually don't write, but in this case we're going to write it, so we're going to have 1 plus 1 divided by 1 plus 1. And then plus, we have 1/2 here, and we don't see an x term here, but there's really an x to the 0 power term. We can look at it as x to the 0 because x to the 0 is equal to 1. So 1/2 times x to the 0 is equal to 1/2. So 0 plus 1 divided by 0 plus 1. And this all simplifies to, we get x to the 4th divided by 4 plus 3x cubed, and 2 plus 1 is 3, so it cancels with the 3 up there, so that's going to cancel, plus 5x squared divided by 2, and then this we can just write as 1/2 x plus a constant. And this would be your antiderivative of this. And if you ever want to check your antiderivatives, you can just take the derivative of it and you should get back what you integrated. So here's another problem. So we're going to integrate x to the 1/2 power plus 1 over x plus 1 over x squared dx. So we're going to integrate each of these terms separately since we're adding them. So the first term, using the power rule, we get x to the 1/2 plus 1 divided by 1/2 plus 1. The second term, if we try to use the power rule on 1 over x, we would get something weird. We would rewrite 1 over x as x to the -1 power, and then when we add a power of 1 and divide by that new power, we would end up dividing by 0, which is undefined. That's why we have natural log x. So if you remember, the derivative of natural log x is 1 over x. So therefore, the antiderivative of 1 over x is natural log x. And for this term, we can rewrite it as x to the -2 power and add a power of 1 and divide by that power plus c, and this all reduces to, we get x to the 3/2. 1/2 plus 1 is 3/2 divided by 3/2 plus natural log x plus x to the -1 power divided by -1 plus c. And we can rewrite this as 2/3 because you just flip the reciprocal and multiply it by your x. Natural log x plus, we can rewrite the x to the -1 power as 1 over x, so, and it's negative, so -1 over x plus c. And that is your antiderivative for this function. So here's another one. We're going to integrate 3x squared plus 4 divided by the square root of x. Now this looks kind of complicated, but we can just split it up into two separate fractions. So let's just rewrite it as the integral of 3x squared divided by square root of x plus 4 divided by root x dx. And now we can just integrate each of these separately. So let's look at the first term. So the integral of 3x squared divided by root x. Well, we can rewrite this as 3x squared divided by x to the 1/2 power. And we could move this denominator into the numerator by putting it in a negative power. So that'll become 3x squared times x to the -1/2 power. And we can combine the exponents, so we're just going to add the exponents, and it's going to become 3x to the -3/2 power, or no, positive 3/2 power. So now we're going to just integrate that. So all we did was rewrite it into something that we know how to integrate. We're integrating 3x to the 3/2 power. Using the power rule, that becomes 3x to the 3/2 plus 1 divided by 3/2 plus 1 plus c. And that could reduce to, it would become 3x to the 5/2 divided by 5/2, which equals 2/5 times 3 x to the 5/2, and 3 times 2 is 6, so 6/5 x to the 5/2. Now for our second term, we're going to add these two after. So our second term was 4/square root of x. Let's rewrite this in the same way we did the previous term. So 4 divided by x to the 1/2 power, and then rewrite that again as 4 times x to the negative 1/2 power. And now we're going to integrate this. So integrating 4x to the negative 1/2 power, using the power rule, we would get 4x to the negative 1/2 plus 1 divided by negative 1/2 plus 1. And that simplifies to 4x to the positive 1/2. So positive 1/2 divided by 1/2. And we could flip the denominator, so it would become 2 times 4, which is 8x to the 1/2 power. If you want, you can rewrite it as 8 times the square root of x. So now putting that together, our answer would be 6 divided by 5, x to the 5/2 from our first term, plus 8 root x, plus a constant.